In the silence of the cosmos, time has often been imagined as a straight arrow, fired from the dawn of creation, flying ever onward toward an unseen horizon. Others have envisioned it as a circle, forever closing in on itself, repeating endlessly. With no beginning, no end, but nature whispers of another shape. Across the universe, in galaxies turning, with arms of light, in the shells of nautilus fossils, in the invisible coils of DNA, there emerges a pattern more intricate, more mysterious. The spiral. It winds forward, yet always curves back, repeating without repeating, echoing without ever returning to the same point. What if time itself is written in this form? Not a line vanishing into the void, nor a wheel forever retracing its path, but a spiral that carries the past within it, folding memory into motion. A pattern that preserves what has been, even as it advances into what has not yet come. Einstein bent time around gravity. Quantum theory fractured it into uncertainty. Cosmology traced it back to a beginning. Yet still the spiral rises, across scales, across forms, as if reminding us that the story of existence may not be linear at all. Does the universe repeat itself in endless spirals of birth and death? Is human consciousness itself a spiral, memory, looping forward through the architecture of the brain? Could time be layered, each moment tied invisibly to others across dimensions unseen? The spiral is at once infinite and intimate, vast and fragile. To follow its curve is to ask, is time not simply passing, but returning again and again in the endless spiral that connects all moments? Long before science traced equations across chalkboards or detectors hummed in the silence of laboratories, humanity sought to understand the hidden rhythm of existence. In caves and on stones, the spiral appeared again and again, carved by hands that did not yet know the names of stars. Prehistoric artists incised its coiling lines onto shells, bones, and sacred rocks, as though they sensed in its endless curve a truth too deep to name. These spirals were not decoration, they were symbols. To early cultures, they represented birth and death, the turning of seasons, the circling heavens. The spiral carried within it the idea of return, yet also the promise of forward motion. It was the earliest human whisper of time's possible shape. Ancient mythologies preserved this vision. In Hindu cosmology, time was not an arrow, but an ocean of cycles. The yugas, vast epochs spiraling through creation, destruction, and rebirth. The Mayans inscribed cycles into their calendars, imagining history not as a straight line, but as a repeating spiral of ages, each echoing the last, yet never precisely the same. Among the Greeks, the spiral appeared in the labyrinth, a winding path symbolizing both entrapment and revelation. And in philosophy, the eternal recurrence haunted the imagination, most famously in Friedrich Nietzsche's vision that every life might return, not once but endlessly, in variations across the eternal spiral of existence. Yet for many centuries, science abandoned these intuitions. With the Enlightenment came a vision of time that was mechanical, absolute, and linear. Isaac Newton's equations imagined time as a vast, invisible ruler, unchanging, universal, ticking forward identically for all observers. In his view, time was the perfect stage upon which matter moved, never bending, never breaking, indifferent to the spirals carved by myth and art. This was the triumph of certainty, the arrow of time as infinite and eternal. But the cosmos would not remain so simple. By the early 20th century, Albert Einstein shattered Newton's absolute with his general theory of relativity. Time was not rigid. It bent with gravity, stretched with motion, and curved within the geometry of space-time. Itself, around massive stars and galaxies, time could slow, even loop, circling like a whirlpool around a drain. The spiral returned, not in myth this time, but in physics. Einstein's insights were followed by a revelation that spirals did not merely belong to equations, but were inscribed across the heavens. In 1920, Edwin Hubble turned his telescope toward faint smudges of light and uncovered that these were not nebulae within the Milky Way, but entire galaxies, immense structures beyond our own. Many of them spun in vast spirals, arms of dust, gas, and stars coiling outward like the whirls of a fingerprint. These spirals became not only symbols, but monuments of time itself. Each rotation of a galaxy marked billions of years. Each spiral arm preserved the record of stellar birth and death. The universe, once thought static, revealed itself to be dynamic, swirling, spiraling through time. While astronomers traced spirals in the stars, biologists uncovered them in the foundations of life itself. In 1953, James Watson and Francis Crick announced their model of DNA, guided in no small part by Rosalind Franklin's X-ray diffraction images. The double helix, a spiral ladder twisted upon itself, was not merely structure, but memory. Within its coils lay the instructions for life, passed across generations, spiraling forward through time. The same pattern etched in galaxies was found within the nucleus of a single cell. The spiral had become not just metaphor, but mechanism, the very architecture by which time preserved itself in biology. The convergence of these discoveries began to reveal that spirals were not accidents of form, but expressions of deeper laws. Galileo had once noted the spiral paths of projectiles under gravity. Johannes Kepler described planetary orbits as ellipses, but even these, perturbed by other forces, often traced spiral patterns. In the wake of relativity, Carl Schwarzschild, solving Einstein's equations, revealed the strange geometries around black holes, where matter and light spiral inward toward horizons from which they cannot escape. Everywhere science looked, from the largest structures in the universe to the smallest blueprints of life, the spiral emerged again, whispering of recurrence, of return, of progression wrapped around memory. Yet the spiral's power was not only in what it revealed, but in what it suggested. If galaxies, stars, and DNA all bear this form, could time itself follow the same pattern? Was the arrow of time, so linear in Newton's mechanics, more like the spiral of myth and biology moving forward, yet carrying with it echoes of its past turns? The scientists who uncovered these patterns could not ignore their resonance. Einstein himself, though cautious of philosophical speculation, admitted that relativity's curving time resembled something far stranger than Newton's straight progression. Edwin Hubble, upon discovering the expansion of the universe, hinted that perhaps the cosmos itself was not simply stretching, but evolving in cycles, spiraling outward from its mysterious origin. Rosalind Franklin, though never alive to see the full recognition of her work, left behind an image that symbolized far more than genetics, a spiral of life that embodied both continuity and change. In laboratories and observatories, the spiral became a bridge between disparate fields. Astronomers studied galactic spirals as records of cosmic evolution. Biologists studied DNA spirals as records of genetic time. Mathematicians uncovered logarithmic spirals scale invariant and self-similar, appearing in hurricanes, seashells, and even the distribution of galaxies. Physicists, probing relativity and quantum mechanics, encountered spirals in the trajectories of particles, their tracks winding within magnetic fields, sketching invisible laws onto photographic plates. Across all of these discoveries, one theme emerged: the spiral was never closed. Unlike the circle, it carried memory without repetition, change without forgetting. This opened a haunting possibility. If time itself was not a straight arrow, nor a perfect loop, but a spiral, then history might return, but not identically. The universe might echo itself endlessly, but each echo altered, each recurrence carrying the memory of the last. The discovery phase of the spiral mystery, then, is not the story of a single moment, nor a single genius. It is the slow awakening of human perception, tracing the pattern from myth to mathematics, from cave carvings to cosmic telescopes. It is the recognition that spirals are not surface phenomena, but signatures of something deeper, a hidden architecture beneath matter, beneath life, perhaps beneath time itself. The spiral carves through prehistory, where humans saw eternity in the curve of a shell. It carves through philosophy, where thinkers imagined cycles of rebirth. It carves through science, where galaxies, black holes, and DNA revealed the same form across scales. Each discovery was not separate, but a turn of the spiral itself, memory, carried forward, knowledge coiling upon itself into deeper understanding. And yet, these revelations carried with them an unsettling undertone. If the spiral is truly the hidden geometry of existence, then perhaps time itself is not linear progress, but a winding curve, always advancing, yet always circling back. The discovery of spirals across nature and science was not merely aesthetic, but existential. It suggested that the very fabric of reality may hold memory, that the past is not erased, but carried forward in coils invisible to us. The spiral, it seemed, was not only everywhere in nature, but everywhere in time. The spiral had revealed itself across myth and matter, from the arms of galaxies to the coils of DNA. Yet, when physics confronted time directly, the revelations were not gentle. They were shocks, fractures in understanding, ruptures that forced humanity to reconsider not only what time is, but whether it can be trusted at all. The first fracture came with Einstein's theory of relativity. Newton's time had been absolute, universal, a ticking metronome to which all events obeyed. Relativity shattered this simplicity. Time was not universal. It was local, elastic, and malleable. It bent with motion, stretched with speed, slowed. In the presence of gravity, two twins, one traveling near the speed of light, could meet again to find that one had aged while the other remained young. This was no longer a metaphor. It was measurable. Time itself could coil differently for different observers. The arrow of time was no longer straight, it was curved, and in that curvature lay the hint of a spiral. But relativity carried deeper shocks. In 1949, the logician Kurt Gödel, working with Einstein's equations, discovered solutions that allowed what physicists call closed time-like curves, paths through space-time that loop back on themselves. In such a universe, one might travel forward only to return to the same point, not in space, but in time. The mathematics described a spiral of time itself, circling endlessly. What had once been myth, cycles of history, eternal recurrence, now emerged from the most rigorous equations of modern science. Gödel's solution was unsettling, not because it was fanciful, but because it was consistent. Relativity allowed spirals of time. The quantum revolution added another layer of strangeness. In the delayed choice experiments, physicists found that a decision made in the present could influence the outcome of an event that seemed already determined in the past. Photons, particles of light, behaved differently depending on whether or not an observer chose to measure them, even after they had seemingly completed their journey. The present reached backward, cause and effect twisted. Time no longer resembled an arrow. It resembled a spiral, folding past and future into a single enigmatic structure. Then came cosmology. By mid-century, it became clear that the universe itself was not eternal and unchanging, but expanding from an origin point, the Big Bang. Yet cosmological models soon suggested more unsettling possibilities. Oscillating universes, expanding and contracting, rising and falling in infinite cycles. The cosmos itself could spiral through ages of birth and death. Even the most modern versions, inflationary universes bubbling into existence, or Roger Penrose's conformal cyclic cosmology, where each eon births the next, bore the unmistakable trace of recurrence. Each universe might be unique, but each carried echoes of the one before. As though time itself spiraled from origin to origin, the spiral of shock was not confined to the cosmos. In biology, the discovery of DNA's double helix was followed by a second realization. Within that spiral lay memories billions of years old. Genes were not simple instructions. They were records, mutations preserved, failures remembered, successes carried forward. The spiral of life did not erase its past. It carried it, generation upon generation, coiling time into the very substance of living matter. The DNA spiral was not symbolic. It was literal memory, proof that time itself could write into matter. These revelations unsettled philosophy as much as physics. The arrow of time, once thought to flow cleanly from past to future, appeared increasingly fragile. Relativity allowed spirals where cause and effect lost distinction. Quantum experiments suggested the present could reshape the past. Cosmology whispered that the universe itself might recur, each cycle echoing the last. Biology revealed that life's spiral preserved history within its form. The shock was not only scientific, it was existential. What does it mean if time is not linear? If moments return, not identically but altered, memory carried forward but never erased? In Nietzsche's vision of eternal recurrence, the weight of existence lay in repetition, but in the scientific spiral, the weight is subtler. Each turn is new, yet bound to those before. Every decision is both unique and an echo. Every life is both singular and entangled with lives that came before. The spiral blurs categories of past, present, and future, until they are not separate but continuous. This is why the scientific community met these revelations with resistance. Einstein himself was uneasy with Gödel's time loops. Many physicists dismissed oscillating universes as speculative, preferring the clarity of a single origin. Quantum paradoxes were often set aside as puzzles of interpretation rather than reflections of reality. Yet the spiral remained. It returned in equations, in data, in structures across scales. The emotional weight of these discoveries cannot be overstated. For centuries, time was the most certain of concepts. Everyone experienced it, everyone trusted it, everyone built their lives upon its arrow. To learn that time might not be absolute, that it might coil, loop, or spiral back upon itself, this was more than a scientific shock. It was a rupture in the human sense of reality. Consider the twin paradox. A journey to the stars could result in one twin returning decades younger than the other. In such a world, what does simultaneous mean? The answer is simple. It means nothing. Time is not universal. It is a spiral around motion and gravity, bending experience into paths that cannot be reconciled. Consider closed time-like curves. If the universe permits them, then the past is not fixed, but accessible. Causality itself could spiral, collapsing our categories of before and after. What would it mean to live in such a world? A world where choices today ripple not only into the future but into the very fabric of what we call the past. Consider DNA. In every cell, in every human, coils a spiral that remembers. It remembers the hunger of ancient bacteria, the resilience of plants, the long march of mammals through extinctions and survival. The spiral of life contains within it the time of Earth, preserved not in memory but in matter. To realize that our bodies are spirals of time, this too is shock. And finally, consider the universe itself. If cosmology's whispers are true, then this moment, now, may not be the first. The universe may have lived before, spiraled into collapse, and emerged anew. It may do so again. Our existence may be one curve on an infinite spiral of worlds, each carrying echoes of the last. The Big Bang may not be a singular birth, but a turn in a cosmic cycle. The first moment may not be first at all. These shocks have left physics and philosophy unsettled for over a century. They challenge the most basic assumptions, that time is absolute, that cause precedes effect, that history is unique. They replace certainty with spirals, linearity with recurrence, simplicity with paradox, and yet, in these spirals lies beauty. The realization that the universe is stranger than myth, that reality bends closer to poetry than mechanics, that time itself may coil into patterns as intricate as seashells and galaxies. The shock of the spiral is not only disorientation, it is wonder. The scientific shock of the spiral is this: time may not be what we thought it was. It may be deeper, more intricate, more cyclical, and yet progressive than our minds can easily hold. The spiral does not erase the arrow. It bends it. It carries it forward, but never lets it escape the memory of its past. In that shock lies the first glimpse of truth. Time is not simple. It is not safe. It is a spiral that connects all. Moments weaving past into future, folding cause into effect, preserving memory in the very act of motion. The shock of spiraling time left humanity reeling. But science does not end in astonishment. It pushes forward, demanding data, demanding patterns. If time truly curved, coiled, or spiraled, then somewhere in the cosmos, in the brain, in the mathematics of nature, its traces should remain. The next step was not wonder alone. It was investigation. The first evidence came from the faintest of signals, the cosmic microwave background, the afterglow of the Big Bang itself. In the 1960s, Penzias and Wilson stumbled upon its whisper, static etched across the sky. But decades later, satellites such as COBE, WMAP, and Planck sharpened this echo, mapping the early universe in exquisite detail. The CMB was not uniform. It bore fluctuations, tiny ripples that would later seed galaxies. And hidden within those ripples, some scientists searched for spirals, circular imprints, recurring patterns, signatures that might suggest the universe was not born once, but had cycled before. Teams combed the data for evidence of Penrose's conformal cyclic cosmology, concentric rings that might carry the memory of collisions in a universe older than our own. The verdict was not decisive, but the hunt itself revealed how far science was willing to chase the spiral. Inflationary theory added to the puzzle. This idea that the universe ballooned faster than light in its first fraction of a second predicted subtle spirals of polarization in the microwave background. These B-modes, swirling patterns in light, became a holy grail. If confirmed, they would reveal not just expansion, but a spiral memory inscribed into space-time itself. For now, the evidence is tantalizing, contested, incomplete. Yet the pursuit continues, for in those spirals may lie proof that time itself, once coiled upon creation, the arrow of time has long been linked to entropy, the second law of thermodynamics. Order decays, disorder grows, energy spreads. This law gives direction to existence. From ice melting to stars burning out, the universe drifts from structure to chaos. But even entropy carries hints of spiraling rather than linear change. Complex systems, storms, hurricanes, galaxies resist decay by forming vortices, spirals that temporarily harness disorder into shape. Entropy drives time forward, but in that drive, spirals emerge again and again, as if time itself prefers to coil rather than fall straight. Fractals deepened this insight. In the late 20th century, Benut Mandelbrot showed how complexity often arises through self-similarity, patterns repeating across scales, each iteration echoing the last. Spiral galaxies mirrored whirlpools, which mirrored seashells, which mirrored hurricanes. The mathematics of fractals suggested that nature does not simply progress, it iterates, spiraling outward with variation. Time too might be fractal, each epoch an echo of the last, not identical but similar, carrying memory forward through repetition with difference. The investigation reached inward as well. Neuroscience began mapping memory itself, probing the hippocampus, the brain's keeper of time. Scientists found that neurons fired not only in sequences, but in loops, oscillations that bound events together. Time was not stored as a line, but as a rhythm, a spiral of activity that gave continuity to experience. When people recalled their past, the brain reactivated patterns in waves, circling through memory like a spiral staircase, ascending while returning to the same place. The structure of recall itself resembled the cosmic metaphor, recurrence with progression. Time in the brain was not arrow-straight, it was looped, coiled, dynamic. Mathematics added precision to these images. The logarithmic spiral, discovered by Descartes and later studied by Jacob Bernoulli, was remarkable. Infinite, yet self-similar, expanding without bound, yet always retaining its form. From the Nautilus shell to galaxies, this spiral carried a property physicists call scale invariance. Time, some theorists suggested, might share this property, not merely passing, but scaling. Each cycle linked to the next by hidden invariance. If so, then recurrence would not be illusion, but architecture. In laboratories, accelerators pushed matter to its limits. When particles collided at near-light speeds, detectors revealed spiraling tracks. These were not metaphors, but literal paths. Matter and antimatter curving through magnetic fields, leaving spirals etched in data. Each spiral was a signature of deeper symmetries, clues to the forces binding the universe. Some physicists speculated that these patterns might hint at time's underlying shape, that the spiral, appearing in collision after collision, was more than coincidence. It was a trace of how reality itself organizes motion, memory, and decay. Investigations multiplied across scales. Physicists tested whether entropy might one day reverse, if time could spiral back upon itself. Cosmologists explored whether expansion might eventually give way to contraction, a bounce that would loop the universe into recurrence. Biologists studied how DNA spirals not only encode genes but regulate them in rhythms, oscillations of expression that spiral through generations. Everywhere, spirals carried memory forward. Everywhere, they suggested time was not simple passage, but layered structure. The philosophical implications grew heavier. If time spirals, then memory itself may be structural to the cosmos. The universe might not forget its past, but embed it into every cycle. Our lives, our histories, our civilizations might be part of a larger recursion, not doomed to repetition, but destined to echo. The investigation did not resolve this question, but it deepened it. The spiral was no longer myth or metaphor. It was evidence, appearing across instruments, equations, and experiments, and still, mysteries emerged. The CMB data showed anomalies, cold spots, alignments that some suggested might be relics of previous cycles. Inflationary models hinted at spiraling imprints, though yet unproven. Fractals showed recurrence across scales, but whether time itself was fractal remained elusive. Neuroscience revealed spirals in memory, but whether consciousness itself was bound to a deeper spiral of existence remained unsolved. Each investigation uncovered more questions, more spirals hidden within spirals. What had begun as a metaphor was now an empirical hunt. Telescopes scanned for cosmic spirals in the afterglow of creation. Colliders revealed spirals in matter itself. Brain imaging traced spirals in thought. Mathematics etched spirals into the infinite. Again and again, the pattern returned. Perhaps the most haunting question was not whether spirals exist, but whether they are coincidence or necessity. Is the spiral a byproduct of physics, arising wherever systems evolve? Or is it the fundamental form of time itself, the hidden geometry of reality? In searching for answers, humanity found itself reflected. For what is memory but a spiral of experience? What is history but a spiral of cycles? What is science itself but a spiral of questions circling back upon themselves, each turned deeper than the last? The deeper the investigation went, the more it seemed that time could not be reduced to a line. Its traces were everywhere, and they were spiraled. The mystery was no longer whether time spirals. The mystery was how far the spiral goes, whether it stops at galaxies and DNA, or whether it coils all the way through existence, binding every moment into a single endless curve. The spiral had revealed itself across scales, in galaxies, in DNA, in memory, in mathematics. But what began as patterns soon grew into paradox. For if time is truly spiral, then reality itself must bend in ways more extreme, more disquieting than science had ever dared to imagine. Black holes became the first crucible of this escalation. Einstein's equations showed that rotating black holes, Kerr black holes, do more than trap light. They drag space-time itself into motion, twisting reality into whirls around them. This phenomenon, called frame dragging, was later confirmed by satellites orbiting Earth. The Gravity Probe B mission measured tiny shifts in gyroscopes, proving that even our planet twists time as it turns. Yet near a black hole, this twisting intensifies into something far stranger. Time itself coils, spiraling around the abyss, as if the universe's own clock were being wound in circles. Some solutions to Einstein's equations even allow closed time-like curves, spirals of time that loop back into the past. Whether such paths could ever be real remains uncertain, but the equations whisper of possibilities that unsettle reason. From black holes, the spirals spread outward into speculation of tunnels, wormholes, gateways where space-time might fold upon itself, linking distant moments, distant places. Some physicists imagined that traveling through such spirals of time might allow journeys into the past. Others warned that paradoxes would abound, that causality itself might unravel. And yet, the mathematics permits it. Time, when coiled tightly enough, may not remain linear at all. It may loop, it may spiral back into its own origin. The universe itself carried echoes of spiral recurrence. Galaxies, those vast swirls of stars, do not remain unchanged. They wind more tightly as they age, their arms curving inward, as though cosmic time were mirrored in their shapes. Astronomers studying galactic evolution found patterns of tightening, an arrow of history inscribed in spirals of light. Perhaps the spiral is not only symbol but destiny, galaxies recording in their arms the same spiral flow that may govern time itself. And beyond galaxies, the cosmos escalated the mystery still further. The discovery of dark energy at the turn of the 21st century revealed that the universe's expansion is accelerating. Rather than slowing, as once imagined, space itself is stretching faster, spiraling outward into an unknown future. The geometry of this acceleration remains elusive, but some theorists imagine it not as simple linear growth, but as exponential spiraling, each epoch expanding faster than the last, time itself accelerating with distance. In this model, the universe does not simply expand. It races outward in a spiral, carrying memory along with it. Quantum entanglement deepened the paradox. Here, pairs of particles remain linked across distance, their states intertwined beyond space and time. To some physicists, this connection hints that time itself is not linear but layered, a spiral with hidden dimensions binding distant moments. Theorists like Maldacena propose that wormholes and entanglement may be two faces of the same phenomenon, spirals of connection woven into space-time. If so, then time is not simply arrow or cycle. It is tapestry, threads spiraling across dimensions, linking the near and the far, the past and the future. The emotional weight of these discoveries cannot be understated. If time spirals, then history itself may not be unique. Events may echo endlessly, not identically, but altered with each recurrence. Wars, extinctions, even personal lives might play out in spirals, repeating, shifting, echoing across the cosmos. Nietzsche's eternal recurrence, once philosophy, once myth, now gained eerie resonance in the light of modern physics. Was existence itself spiraling, forcing everything to return in altered form? Or was each turn of the spiral wholly new, repeating only in rhythm, not in detail? The dread rose from the possibility that there may be no true escape from recurrence. If the universe spirals, then each end might contain its beginning. The Big Bang may not have been unique, but one of countless rebirths, each cycle spiraling out, collapsing and spiraling again. Some models predicted infinite bounces, others a progression of cycles, each universe layered upon the last. But in every case, the spiral replaced finality with recurrence, and recurrence carries with it unease. For if all has happened before, and all will happen again, what room remains for freedom, for novelty, for meaning? Black holes again sharpened the terror. The information paradox, the puzzle of whether matter falling into a black hole is lost forever, forced physicists to confront the fragility of knowledge itself. If information vanishes, then time's spiral might break, history itself erased. Yet if information endures, encoded perhaps on the event horizon or projected holographically into new universes, then time's spiral might be deeper still. Each collapse, each death of a star, might seed a new spiral of time, echoing endlessly across realities. In either case, the spiral deepens into enigma. Either memory can be destroyed, or it recurs forever. Both possibilities are haunting. Cosmic acceleration carried its own dread. If dark energy continues unchecked, the universe may spiral into a big rip. Every galaxy, star, and atom torn apart as expansion overwhelms gravity. Time itself may unravel into a spiral of dissolution, each moment stretched thinner until nothing remains. Yet even here, some theorists imagine rebirth. In the ashes of dissolution, quantum fluctuations might ignite new universes, spiraling existence onward again. Emotionally, the spiral became double-edged, promise and trap. On one hand, it offered renewal, the possibility that nothing is ever lost, that each death contains the seed of return. On the other hand, it threatened eternal recurrence, a prison of echoes, cycles repeating forever. To live in a spiral universe may mean that humanity is both immortal and bound, destined to rise again, but never wholly free. Philosophy strained beneath these possibilities. Was the spiral of time liberation, proof that nothing is ever truly gone? Or was it entrapment, condemning existence to endless repetition? Even science, built on equations and data, could not escape the emotional undertone. For spirals are not only shapes, they are metaphors of destiny. At this stage, the mystery was no longer abstract, it was existential. If time spirals, then the meaning of life itself is altered. History may echo, memory may endure in ways we cannot perceive, and the future may not be uncharted but a curve, already bending back toward what has been. The escalation was clear. Spirals in black holes, spirals in galaxies, spirals in cosmic acceleration, spirals in entanglement. Each discovery layered the mystery deeper, until time itself seemed to coil around humanity, pulling thought, science, and philosophy into its vortex. And yet, in the heart of this deepening paradox, the spiral still carried wonder. For to spiral is not to repeat perfectly, but to evolve. Each turn of the spiral is both return and advance, both echo and transformation. Perhaps, then, existence is not trapped, but unfolding. Perhaps the spiral carries forward everything that has been reshaped, renewed, reborn. In this way, the spiral is not only terrifying, it is also hopeful. For in its endless curves, it may hold the promise that nothing is ever wholly lost, that every moment returns, altered but alive. The spiral deepens the mystery of time, but it also deepens its beauty. As the spiral deepened, science could not resist the pull of speculation. The evidence pointed toward recurrence, toward patterns hidden within patterns, and so physicists, cosmologists, and philosophers turned to theory, to frameworks bold, enough to describe a universe where time itself may coil. One of the most enduring ideas was that of the cyclic universe. In this vision, the cosmos does not begin once and end once, but breathes endlessly. Expansion follows collapse, each big bang reborn from the ashes of a big crunch. Ancient myths spoke of such rhythms, but now physics gave them mathematical flesh. Models of oscillating universes, explored through general relativity, imagined time as an infinite heartbeat, spiraling across eons. Each cycle would differ from the last, expanding further, cooling faster, accumulating the echoes of what came before. Here, the spiral is not metaphor, but mechanics, existence as the endless return. From this grew refinements such as the Big Bounce, a theory born of attempts to merge relativity with quantum physics. In loop quantum cosmology, space-time is not smooth but granular, woven of quanta that resist infinite collapse. Instead of a singularity at the Big Bang, the universe rebounds, collapsing into unimaginable density, then springing outward into new expansion. Each bounce could carry traces of previous cycles, spiraling memory forward across cosmic generations. The spiral here is protective, preventing infinities, preserving existence through repetition. Yet others pushed speculation further. Roger Penrose's conformal cyclic cosmology proposed that universes do not collapse and bounce, but instead fade into one another. In his model, when all matter decays, when even black holes evaporate, the universe becomes pure radiation. In such a state, there is no meaningful scale of time or size. The death of one cosmos becomes, through mathematical transformation, the birth of another. Eons succeed eons, spiraling endlessly, each linked through the faintest imprints. Penrose even suggested evidence in the cosmic microwave background, concentric circles, possible echoes of collisions between black holes in a universe before ours. If true, then our universe itself is a spiral within an infinite procession. Other theories turned to the very fabric of space-time. String theory, with its curled extra dimensions, imagines reality woven from loops and vibrations. Within its equations, the geometry of space can spiral at scales beyond perception, tiny helices shaping the laws of physics we experience. Time, too, may be embedded within these spirals, emerging not as a straight line, but as a resonance, a coiling of hidden dimensions into the flow of existence. Quantum physics added its own strangeness. Some interpretations allow closed time-like curves, paths where time folds back upon itself. In these spirals, one could travel into the past, meeting oneself, looping causality into paradox. While most physicists doubt such curves could ever be physically traversed, they remain solutions to Einstein's equations. The mathematics of time does not forbid spirals. It whispers them. Speculation extended into the vast frontier of the multiverse. If inflation, the rapid expansion thought to have occurred in the universe's earliest moments, never truly ends, then countless bubble universes may be born, each expanding outward. These bubbles might collide, overlap, or spiral outward together, forming an infinite fractal of realities. Each universe would carry its own arrow of time, yet collectively they might trace a spiral through the multiverse itself. Some physicists imagine that our universe's birth was not singular, but one branch of a spiral of creation branching endlessly outward. Yet the spiral was not only cosmic. At the quantum scale, some theorists suggested that information itself may spiral. The holographic principle, emerging from studies of black holes, proposes that all the information within a volume of space may be encoded on its boundary. In this vision, reality is projection, memory preserved at the edges. Spirals of entropy, spirals of information, could shape the unfolding of time. The arrow of time itself may be an emergent spiral of computation, each moment storing and reprocessing. The past. Philosophy to bent toward spirals. Nietzsche's eternal recurrence suggested that all events repeat, not once, but infinitely. Each joy, each sorrow, each life returning in endless cycles. Modern science does not prove this, yet cosmology's cycles resonate with it, eons. Repeating, universes recurring. Whitehead's process philosophy imagined reality as a series of moments spiraling into becoming, each building upon the last, never static, always unfolding. The spiral became a bridge between physics and thought, a geometry of existence felt as much as measured. Other speculations grew more daring still. Could time itself be an illusion, a projection of deeper structures? Some theorists argue that time may not exist fundamentally, but emerge from correlations, from entanglement, from quantum states unfolding in patterns. If so, then the spiral is not merely a shape in time, but the very process by which time arises. Time may not pass. It may spiral into being, constructed moment by moment from hidden layers of information. The spiral also reached into biology. The double helix of DNA, discovered in 1953, is more than code. It is memory spiraled into matter, life preserving its past within coils. Here, too, the spiral carries time forward, not abstractly, but concretely, generations encoded in structure, spiraling across billions of years. Speculative thinkers suggest that life itself is an expression of the spiral of time, consciousness emerging from matter's ability to record, to spiral memory into future form. Even human history seems to trace spirals. Civilizations rise and fall, patterns recur, yet never identically. The spiral of time may govern not only stars and atoms, but culture, thought, memory. In this reading, science and myth converge. Time spirals through all things, yet every speculation carried tension. Was the spiral liberation, proof that nothing is ever lost? Or was it entrapment, condemning all to recurrence? If time spirals endlessly, are our choices real or merely echoes? Science could not resolve this, but it could reveal that the spiral is not metaphor alone. It is written into equations, into galaxies, into DNA, into the structure of memory itself. Theories and speculations thus converge, from cosmic cycles to multiverse branches, from quantum curves to biological helices. The spiral emerges again and again. Each theory offers not a final answer, but a glimpse of how time might curve. Perhaps it is line, perhaps circle, but more likely it is spiral, both progression and recurrence, memory and motion, echo and transformation. Speculative though they remain, these theories embody science's most profound ambition to follow the spiral to its source, to its future, to its infinite unfolding. In the spiral, science meets philosophy, physics meets myth. For the spiral is not only a symbol, it may be the geometry of reality itself. The spiral of time is not only a metaphor whispered by galaxies and memory, it is a hypothesis tested by machines of steel, mirrors, and mathematics. To glimpse whether time itself coils rather than flows, science turns to its most powerful instruments. Telescopes peering into the earliest light, detectors listening to the faintest ripples, colliders smashing particles at energies once found only at creation. The cosmic microwave background, that faint afterglow of the Big Bang, has become one of the most profound canvases for testing spirals in time. satellites such as COBE, WMAP, and most recently, Planck mapped its subtle variations across the sky. These patterns hold fossilized imprints of the infant cosmos, ripples of density that later grew into galaxies. Some cosmologists search for circular or spiral imprints in this radiation patterns that could suggest a cyclic universe, traces of previous eons overlapping with our own. Roger Penrose's conformal cyclic cosmology even predicts concentric circles, potential scars left by black holes in universes that existed before the Big Bang. The search continues, pixel by pixel, for hints that time itself carries memory into each new expansion. On Earth, vast mirrors and detectors stretch across deserts and mountains to listen not to light, but to vibration. The laser interferometer gravitational wave, Observatory LIGO, joined by Virgo and Cagra, has recorded space-time itself rippling as black holes spiral into one another. Each detection is not only confirmation of Einstein's relativity, but also a window into how time behaves in extreme conditions. The spirals of merging black holes are more than cosmic dancers. They are literal spirals in space-time, written as waves that reach our planet. Soon, with the planned Laser Interferometer Space Antenna, LISA, humanity will send detectors into orbit, sensitive enough to capture the spirals of supermassive black hole mergers from billions of light-years away. These are tests of relativity, but also of deeper questions. Do these spirals encode the structure of time itself? In laboratories, the spiral emerges in unexpected places. At CERN's Large Hadron Collider, when particles collide at nearly the speed of light, their fragments trace spirals in magnetic fields. These spirals are not metaphors, but measurements, each curve carrying data about forces and symmetries at nature's foundation. Physicists examine them for hints of symmetry breaking, of laws that distinguish past from future. If a hidden asymmetry in fundamental particles exists, it could explain why time prefers forward motion, why entropy spirals outward rather than inward. To find such asymmetries would be to uncover a mechanism of time itself. Hidden within the spiral tracks of subatomic debris, the search for dark matter and dark energy also carries within it the shadow of the spiral. If dark energy drives the universe's expansion to accelerate, then the cosmic spiral is opening wider with every moment, an outward coil without bound. Instruments such as the Dark Energy Survey and the Euclid Space Telescope are mapping galaxies to chart this acceleration, while underground detectors like Xenon and Lux Zeppelin hunt for elusive dark matter particles. Their findings will not only reshape cosmology, but also touch the spiral directly. If expansion continues endlessly, time's spiral may stretch without limit. If dark energy shifts, the spiral may bend back toward collapse, toward recurrence at the quantum frontier. Physicists explore spirals through information. Quantum computers, still in their infancy, are being used to simulate scenarios where time loops back on itself. Some experiments model closed time-like curves, exploring whether paradoxes could be resolved mathematically. Though still theoretical, these simulations test the idea that causality may not be a straight line but a coil, where present states echo back into past ones. In the realm of thought experiments, quantum systems themselves are spirals, wave functions evolving, collapsing, intertwining, carrying probabilities forward in ways that resemble recurrence. In neuroscience, time spirals are tested not in stars but in synapses. Advanced imaging, from functional MRI to optogenetics, reveals that the human brain encodes time through loops of neural activity. the hippocampus, seat of memory, fires in patterns that spiral through phases of oscillation. Neurons loop activity forward, preserving sequences of events, as though the brain itself were a spiral clock, winding experience into memory. This research suggests that consciousness does not ride passively on time's arrow, but actively coils it into loops of remembrance. If the spiral is universal, it exists as much in thought as in galaxies. Mathematics, too, becomes an instrument. Models of entropy, chaos theory, and nonlinear dynamics reveal spirals at every scale. From the vortices of fluid dynamics to the growth of galaxies, logarithmic spirals recur in equations. These models are tested in supercomputers, running simulations of universes expanding, collapsing, or repeating. Each line of code becomes a hypothesis about time's curve. The spiral thus lives not only in observation, but in abstraction. In numbers that predict and test reality, future instruments promise deeper clarity. The James Webb Space Telescope now peers further back than any eye before, into the first stars and galaxies. Its infrared gaze may yet find signs of structure older than expected, perhaps even hints of recurrence. Planned successors, even more. Ambitious, will map billions of galaxies, searching for repetitions across the cosmic web. If patterns repeat on scales beyond chance, they could be signatures of a spiral universe. Echoes of cycles past. Other missions aim to capture dust and particles directly. Projects like Stardust and OSIRIS-REx have already returned samples from comets and asteroids, relics of the solar system's youth. Yet future missions propose to catch interstellar dust, grains that may predate our sun, in their isotopic ratios, in their structure, could lie evidence of earlier spirals of cosmic history. Each atom a fragment of cycles gone before. The spiral also enters the language of collaboration. Theories of holographic duality, where black holes encode information on their horizons, are tested against gravitational wave data and collider. Results: the union of quantum mechanics and relativity. The long-sought theory of quantum gravity may itself require rethinking time as spiral. Research groups across continents simulate space-time in laboratories, bending light and matter to mimic horizons. In these artificial universes, spirals of information and entropy are traced, tested, compared to theory. Step by step, instrument by instrument, science circles the spiral. It cannot yet say whether time truly coils, but it gathers evidence across every scale: the afterglow of creation, the death of stars, the firing of neurons, the tracks of particles, the expansion of the cosmos. Each tool adds another curve, another turn, another glimpse of a pattern hidden in plain sight. The pursuit is not idle curiosity. If time spirals, then the fate of the universe, the nature of memory, and the possibility of recurrence are all transformed. Do we live only once, or endlessly, each spiral a variation on a theme? Do galaxies expand into emptiness, or do they return, spiraling into birth again? Science does not yet know, but it listens, it measures, it builds, and in each measurement lies the possibility that the spiral will reveal itself, not only in metaphor, but in mathematics. The spiral has carried us across the breadth of science, from galaxies to neurons, from the echo of the Big Bang to the firing of a single synapse. Yet beyond the mathematics, beyond the measurements and theories, there lies the quiet weight of reflection. For what does it mean if time itself spirals? What does it mean for existence, for memory, for meaning? If time is an arrow, life is fleeting. Each moment vanishes into the void, never to return. If time is a circle, life is a prison. Each moment repeats exactly, again and again, without escape. But if time is a spiral, then life is both fleeting and recurring, vanishing yet preserved. The past does not return unchanged, but echoes, altered with each turn. History may rhyme, but it never fully repeats. In this view, every experience is both unique and eternal. Every sorrow, every joy, is a thread woven into a pattern that curves forward without forgetting. The spiral offers a way to reconcile human memory with cosmic time. In memory, events do not disappear. They return, reshaped by reflection. A childhood recalled is not the childhood lived, but neither is it gone. It exists again, spiraling forward in thought. Likewise, galaxies carry in their arms the traces of collisions billions of years past. Their shapes are spirals, not of chance, but of memory, cosmic records inscribed in matter. If the universe itself spirals, then perhaps memory is not illusion, but truth. The cosmos remembers itself, through us, within us, as us. Philosophy has long dreamed of recurrence. Nietzsche's eternal return envisioned life repeating endlessly, every detail recurring in infinite cycles. Ancient myths spoke of ujas, of ages repeating across eons, of Mayan calendars that wound time into stone spirals. Yet science now offers a variation on these dreams, not cycles that imprison, but spirals that transform. If the universe expands, contracts, and expands again, each cycle may differ slightly. New stars, new galaxies, new consciousness emerging with each turn. The spiral rescues recurrence from despair. It transforms repetition into renewal. For humanity, the spiral reframes destiny. Wars may echo through ages, but they need not repeat. Unchanged, civilizations may rise and fall, but each fall carries lessons into the next rise. Even extinction itself, whether of species or of universes, may be less an end than a coiling back into possibility. In this light, the spiral is not a symbol of doom but of resilience, of patterns evolving through recurrence. Yet there is also unease. If time spirals, then are our lives bound to echoes we cannot escape? Do we live the same mistakes, dressed in new forms, again and again? Is history condemned to spiral endlessly through conflict and forgetting? The spiral does not answer. It offers only shape. Whether the curve bends toward progress or decay depends on how patterns are remembered, how they are altered, how they evolve with each turn. The spiral is not fate. It is framework. It provides recurrence with freedom, repetition, with possibility. On a more intimate scale, the spiral binds the human to the cosmos. The double helix of DNA encodes memory across billions of years, spiraling within every cell. The heartbeat pulses in waves that loop through time, each beat new, each beat part of a rhythm that has sustained life for ages. The spiral of breath, inhalation and exhalation, repeats yet carries forward, sustaining existence moment by moment. In the body, in the mind, in the universe, the spiral unites the fleeting with the eternal. The humility of science becomes clear here. Equations stretch far, but none yet capture the essence of time's mystery. Relativity bends time, but cannot explain its flow. Quantum mechanics fractures causality, but cannot unify it with gravity. Cosmology charts cycles but cannot pierce the first or final moment. The spiral is a bridge, a metaphor, perhaps a reality, hinting at order beneath paradox. It reminds science that truth may not be linear, that understanding may itself spiral, advancing, circling back, revisiting questions anew with deeper insight. The existential weight of the spiral rests on a final question. If time spirals, do we live again, not as identical shadows, but as variations upon ourselves? Perhaps lives recur not in detail, but in essence, each echo carrying forward what was not completed before. Perhaps consciousness itself spirals, returning in new forms, across new ages, never wholly lost. Or perhaps the spiral belongs, not to individuals, but to existence as a whole, galaxies, stars, civilizations, rising and falling, like notes in a symphony that repeats but never quite the same. In the silence of reflection, the spiral becomes more than symbol. It is the geometry of mystery, the curve of becoming. Galaxies spin it, DNA encodes it, black holes twist it, and memory preserves it. To imagine time as a spiral is to imagine a universe that never truly loses anything, that carries all moments forward into new shapes. Nothing is erased. Everything is transformed. And so, the spiral is intimate. It whispers that lives are not swallowed by time, but woven into it. That meaning is not lost in death, but carried onward in form, in memory, in matter. The iron in blood once circled in a star. The breath inhaled today once flowed in ancient forests. The ideas spoken now may spiral into futures not yet imagined. Every existence is a curve within a larger curve, each life a line within the infinite coil of time. The closing image is quiet but vast. The spiral not only in galaxies above, but in the rhythm of footsteps below, in the curves of shells, in the loops of thought. Time does not flee, it circles forward. Existence does not vanish, it transforms. The spiral that connects all time is not distant, not abstract. It is here, within every heartbeat, every memory, every atom. Perhaps, then, the spiral is not only the shape of the universe. Perhaps it is the shape of understanding itself. Science, philosophy, and wonder each spiral through questions, never returning to the same point, always moving outward, inward, onward. The spiral holds the paradox, infinite yet bounded, repeating yet new, vanishing yet preserved. The final reflection lingers. Time is not an arrow, nor a circle. It is a spiral, and we galaxies, stars, minds, and lives are carried within its curve, forever returning, forever becoming.